So up to this point, you've seen one-dimensional arrays. In this video, we're going to take a look at arrays of multiple dimensions. So we'll see a way that we could potentially organize our data even further. For example, working with these two-dimensional arrays, we can organize our data into a set of rows and columns. So in this case, we're going to be working with our array declarations where we specify two pairs of brackets. So we're going to have two subscripts. One subscript to indicate the number of rows and then another for the number of columns. Specifically, the first subscript is going to specify the number of rows, and the second subscript will specify the number of columns. So we can see our declaration and our construction of our two-dimensional array right here. So in this case, I'm going to be making a two-dimensional array where the individual items will be of type double. So we're going to specify double as the data type. We then have two pairs of brackets to indicate that this is going to be a two-dimensional array. We'll give it a name. In this case, we call it scores. And we're going to say that this is equal to a new double. So again, we see the new keyword and then the constructor for our array with the data type, and then two pairs of brackets with two numbers inside of them. In this case, we're doing 3. That's going to be our first subscript. And then 4, that's going to be our second subscript. And so 3 is going to specify the number of rows, and 4 is going to specify the number of columns. So then we can see I've given a kind of visual breakdown of how this is all going to look, or how we can imagine this looking in memory. So in the upper left corner, we start with scores 0, 0. So again, keep in mind that arrays are zero-based. So the very first place that you're going to start, we would technically describe that as the 0th position. So in this case, that would mean that we're at row 0 and then column 0. If we imagine this kind of going from left to right and then from the top down, so almost as if you're reading, the next one over is going to be scores 0, 1. So that's going to be at, again, still row 0, but now column 1. The next one over is going to be scores 0, 2. So that's going to be, again, row 0, but now column 2. And then the last one is going to be scores 0, 3. So once again, still in row 0, but now at column 3. And then, of course, you can see the same going from the top down. So maybe going along this leftmost column, we've got 0, 0, 1, 0, and 2, 0. So 0, 0 indicates row 0, column 0. 1, 0 is going to indicate row 1, column 0. And then the last one, 2, 0, we're going to have row 2, column 0. So if we have 0, 0 as the upper leftmost position, so that's kind of the very beginning of our two-dimensional array, the very last position of our two-dimensional array, that bottom right corner, we see scores 2, 3. So we can see that the first subscript, or in this case the first value that we're specifying, is going to be equivalent to the number of rows minus 1, and then the second value is going to be the number of columns minus 1. So in this case, we're doing 2, 3 because we had 3 rows and 4 columns. So let's go ahead and actually put together something like this. So for this one, we can go ahead and do it with scores. So come over to NetBeans and start creating this. So I'll go ahead and do a new Java application. For this one, I'm just going to go ahead and call this one, let's say 2D arrays. Go ahead and click finish. Go ahead and get rid of the extra comments and make some adjustments to the style. And right here, we'll go ahead and put in our declaration and our initial construction of that two-dimensional array. So we're going to say double, and then two pairs of brackets to indicate that it's a two-dimensional array. We'll go ahead and call it scores. This will be equal to a new double, and then we're going to specify that it has 3 rows and 4 columns. Okay, and because of the fact that we are constructing it in this way, where we didn't specify some initial values for it, keep in mind that the value at every one of these positions would be 0. So if we just pick any random value somewhere inside of there, let's say we do something like scores at row 1 and column 2, If we go ahead and run this, then the value we're going to see for it will just be 0.0. So you go ahead and run that, and you see that right there. So every one of these positions currently has a 0 inside of it. So eventually we need to go ahead and actually populate this with some data. So if we were going to do something like that, there are two ways we could approach this. One is we could just go ahead and provide our initial preset values right when we declare it. The alternative would be to just add them one at a time. So let's consider if we go ahead and just put everything in at once. So how would we describe the way that we are structuring this? So a two-dimensional array could also be described as an array of arrays. So notice that you have an array of rows, and that each row is itself another array. So we can kind of see that right here, where I've created this two-dimensional array called numbers. In this case, it's an int array. So we've got the values 1, 2, and 3. You can see that 1, 2, and 3 itself is inside of an array. And then we have a comma, and then we have 4, 5, and 6. That's also in an array. And then a comma, and then 7, 8, and 9. That's in a third array. And then you can see that those three arrays that we have right there are themselves contained in one giant array. So essentially our two-dimensional array is like an array of arrays. So we can see, expanding on this example, the array 4, 5, 6. So that's in the middle of our giant array. Specifically, that's going to be at position 1 of the numbers array. And then the value 6 is going to be at position 2 of that smaller array. So if we wanted to access that 6 inside of it, we're going to need to specify first the array that we're trying to move to within our larger array, and then we're going to specify the specific number within that smaller array that we want to move to. So if we go ahead and put something like this together in our program, so let's say for the scores, we're doing 3 by 4. We can go ahead and do it with just a set of numbers, kind of like what we saw for that example. So rather than just constructing it like this, we'll go ahead and put together our pair of curly braces. So that pair of curly braces will be for the outer array, and then inside of it, we're going to go ahead and put in each one of our inner arrays. So we said that we're going to have 3 rows and 4 columns. So the number of columns says how many items I will have in one of these arrays. So we're going to have 4 of them. So we can do something like 1, 2, 3, and 4. And then the first subscript tells me how many of these arrays I need, or how many rows I need. So if I have 1, 2, 3, 4, this makes up my first one. I need 2 more of these. So I'll have a comma right here. And to more visually represent this, the same way that we saw with that set of rows and columns, I'm going to move this to the next line, and then just kind of move this over a little bit so that we can go ahead and actually place each one of these curly braces underneath the other. So I'll kind of line up everything. So we've got 1, 2, 3, 4. We'll then do 5, 6, 7, and 8. And then finally, for this part, we'll go ahead and do 9, 10, 11, and 12. Okay. So this will give us our 3 rows, and we can see for each one of those 3 rows that is an array. So we've got one array right here, one array right here, and then another array right here. And then inside of each one of those arrays, we've got our individual items. So each one of those individual items makes up its own column. So our first column would be like the values 1, 5, and 9. The next one would be 2, 6, and 10. Then 3, 7, and 11. And then 4, 8, and 12. So we got those 4 columns. So in this particular case, if we still want to print out scores at position 1, 2, that means we're going to go to row 1. So that's going to be this array right here. And then we need position 2 inside of that array. So we're going to go 0, 1, 2. So this 7 right here is what we should expect to see printed to the console. So go ahead and run that, and we can see right here we get 7.0. Okay. So the next thing we'll take a look at is actually trying to iterate over all of the different values of a two-dimensional array. So we've seen a little bit about how to identify a specific position somewhere inside of that array. So now let's consider what happens if we want to try to navigate through all of the positions of the array. So in order to do this, we're going to need two for loops, where we're going to have one nested inside of the other. For clarity's sake, the outer for loop is going to be used to iterate over the rows. So we'll be very explicit about this by actually calling the loop counter for our outer loop row. And then the inner loop is going to be used to iterate over the columns. And we're going to call the inner for loop's loop counter call, just short for column. So I have two different examples right here. The first one is going to be using a traditional array, and then the second one is going to be using a for each loop. So let's start with the traditional array first. So we'll come back over to our program right here. So rather than printing out just a single item, let's go ahead and try to print out all of the items in our scores array. So we're going to say for int row equal to 0. So again, we want to make sure that our loop counters are starting at 0 because that's the beginning position of these arrays. We're going to say as long as this row is less than, in this case we're dealing with 3 items, so we'll go ahead and say as long as this row is less than 3, we can go ahead and say row plus plus. So in this case, we're going to step through rows 0, 1, and 2, which gives us 0, 1, and 2. And then inside of here, we're going to create our inner for loop. That's going to be to step through the columns. So we're going to say for int call equal to 0. Again, making sure that we begin at position 0. And then as long as call is less than 4, so we're going to go through 0, 1, 2, and 3, those 4 different values, incrementing this. And so then as we step through all of this, we'll go ahead and just print each one of those values to the console. So we're going to say system.out.println. And for this one, we want to go ahead and grab our scores array. And we have 2 different values that we need to specify here. The first one is going to be for the row, so we'll put that here. And then the second one is going to be for the column, so that's going to be this one right here. We'll go ahead and save that. I'll go ahead and run this really quick, and then I'll kind of backtrack and explain what this set of for loops is doing, kind of going one step at a time. But just to demonstrate really quick that this actually works, we'll go ahead and run it. And we can see that it's printing out each one of the different values. So you've got 1, 2, 3, 4, 5, and then all of the 6, 7, 8, 9, 10, 11, and 12. So to briefly go through this, at the very beginning, when we first execute this for loop, so this outer one is going to start off with row initialized to 0. We will then come into the body of it. We'll see another for loop right here, so we'll go ahead and execute that one as well. We initialize column to 0, and then we'll come over to our print statement. So we see first we're going to do scores 0, 0. That's going to be this 1 right here. Then we're going to go ahead and restart this inner. So we're going to go to the next iteration of this inner for loop. So in that next iteration, we're going to increment column. We'll check this condition right here, see that that's false. So then we're going to go ahead and use 0 and a 1 right here. So it's 0, 1. That's where the 2 is located. We'll go ahead and move to the next iteration. We'll increment call again. So then we're going to get 0, 2. So we're going to do 0 for the row, 2 for the column. So that's going to be this position right here. And then we'll go ahead and increment once more. Make a column or call 3. So we're going to do 0, 3. That's going to be this 4 right here. And when we increment it again, we're going to see that we now have the value 4 for call. Since 4 is not less than 4, this condition is false. So we're done with the inner for loop. So we're going to come to the end right here. This tells us to go back to the start. So we'll go to the next iteration of our outer for loop. We'll increment row. So now row is going to have the value 1 inside of it. And then when we come back into the body of our outer for loop, we're just going to repeat the process with our inner for loop all over again. But now the row is going to be 1. So now we're going to go through 5, 6, 7, and 8. We will get to the end of the execution for our inner for loop. We'll hit this curly brace right here. So that tells us to come back. We'll increment row once more. So that's going to be the value 2. So then we're dealing with this array right here. Coming into the body of the outer for loop, now row is going to have 2, and we're just going to step through everything for call once more. So that'll give us 9, 10, 11, and 12. We will hit this curly brace, and then when we come up here to increment row again, At that point, row is going to have the value 3. 3 is not less than 3. This condition is false. So we're going to break out of this for loop. So we're going to move back to about right here. But this is going to be the end of the main method, so we just terminate the program at this point. So that shows us essentially how we're going to print out each one of those 12 values to the console. Alternatively, we can go ahead and comment this out. Another way that we could approach this is with a for each loop. So the way that we would do this, we're going to say for. In this case, we're working with a two-dimensional array called scores. The data type of the individual items is going to be double, so we're going to specify that here. But for this outer for loop, I'm specifically going to say that this is a one-dimensional array of doubles. So I'll go ahead and put something like that. So for this one, I'll go ahead and call this something like rows. And so this is going to be the individual rows inside of my scores. So seems like an appropriate variable name for that. And then inside of here, we're going to have the individual items, so the different rows. So I want to go ahead and just grab each one of those. So we're going to say now for a double score from each one of these rows, we want to go ahead and just print that to the console. So we'll go ahead and put, in this case, the score. And I think to make the naming convention a little bit cleaner, we'll go ahead and just make this singular. So for each iteration that we go through this, technically it'll be one row at a time, so I'll make it singular there. So if we go ahead and run this, then again we can go ahead and see the set of values printing to the console. And the difference now is that we're just using a slightly more concise, enhanced or for each loop. So another way that we could approach what I just did, there's something else that we should keep in mind, which is that two-dimensional arrays have multiple length fields. So you might have noticed when I was doing the traditional for loop that I was hard coding the values like 3 and 4 for the dimensions of my outer array and each of my inner arrays. Alternatively, we can just rely on this length field both for our outer and inner arrays. So the length field for the outer array and then length fields for each of the inner arrays, we'll go ahead and work with those. So if you want to get the length of the outer array, that's pretty straightforward. We've already seen that before, where we just take the name of the array and then use that dot notation and then the length. To get the length of each of the inner arrays, we're going to go ahead and specify an array at some position of our two-dimensional array. And then we're going to go ahead and use the dot notation and then the length of that inner array. So if we come back over to this example that we just did, let's go ahead and comment this one out now. And we'll go ahead and uncomment this one. And right here, instead of doing 3 and 4, I'll go ahead and replace this one with scores.length. And then this one, since each one of these inner arrays, they all have the same length, I can pick any one of them. So let's say we do it with the last one, for example. So we can say scores at position 2.length. And so then if we run this, we will get the exact same functionality. We've just made it a little bit more flexible in case the dimensions of this array should happen to change in some way. So if we run this, we still see those values 1 through 12 printing to the console. All right, so the next thing we'll take a look at is calculating totals for both the entire array. We'll also look at being able to get the total for each of the individual rows and columns. So if we want to calculate the total of a two-dimensional array, this is going to be similar to calculating the total of a one-dimensional array. The one slight difference is that now we have to make use out of nested for loops to accomplish this. So in order to do this, what I can go ahead and do is we'll go ahead and comment out this. I'm going to uncomment this line or this section for just a moment so that I can go ahead and just copy this. And then we'll go ahead and leave that one commented out as well, since we want to focus on just our totals now. We'll go ahead and place it here. And so for this one, the general structure of our for loops will stay exactly the same. We're still going to have a double array for our outer loop, and then the actual double so the individual items for the inner for loop. Right here, I want to go ahead and change this so that instead of printing this to the console, what I can go ahead and do is just add this to some total, or add each one of the different scores to a total. So as we saw before, when we're dealing with totals, we need to make sure that we've got some variable to hold that total, so our running total. So we'll go ahead and create, in this case, a double variable called total. This will be equal to 0.0 initially. We'll go ahead and save that. And then coming down here, we're going to go ahead and make use out of that total. So we'll say total plus equals our score. So we see that line of code that pretty much matches up exactly with what we saw when we were getting a total for a one-dimensional array. And save that. And then outside of my for loops, so right here at the very end of my main method, I'll go ahead and actually print out what that total happens to be. We'll do system.out.println, and then we'll put the total right here. So we can see what the sum of all of the numbers 1 through 12 happens to be. So if we go ahead and run this, we can see we get that total right there of 78. So the next thing we'll take a look at is calculating the total of the rows of a two-dimensional array. So again, we're going to make sure that we iterate over the entire array. We're just going to make sure that we're getting the row total as we step through each individual portion of this. The key difference is that this row total must be initialized to 0 once you move to the next row. So if we minimize this, we'll come back over here. So for this next part, we'll go ahead and create our row total up here. So we're going to say double row total. This will also start off being 0.0. For this one, let's say we go ahead and comment all of this out. And then just underneath it, we'll go ahead and create the logic for calculating our row total. So we're going to say for double array that we call row, that's going to be within scores. The first thing we're going to do is make sure that whenever we start a new iteration of this outer for loop, that our row total is set back to 0. So we'll go ahead and do that right here. And then we'll go ahead and put together the inner for loop. So we're going to say for double score within a row. And we'll go ahead and add that to our row total. And then once we actually have that, if we want to actually see each one of those individual row totals before we zero them out back here, we can go ahead and print those to the console. So in order to do this, we have to make sure that this print statement is inside of the outer for loop. I'm going to place that here. So then if we run this, we're going to get 3 different values for each one of the different rows. So we get 10, that's going to be the sum of 1, 2, 3, 4. We'll do 26, that'll be the sum of 5, 6, 7, and 8. And then 42, that's going to be the sum of 9, 10, 11, and 12. And then to briefly kind of break down the logic for this one, we're going to start with our outer for loop. So that's going to give us an array called row. So this very first time we do this, that will give us our first row, or our first array, which is going to be this 1, 2, 3, 4. That's going to be stored into this row variable. We're then going to make sure that our row total is set back to 0. This will make more sense when we get to the next couple of iterations. Right here, we're going to go ahead and do the summing. So we're going to take each one of the individual items inside of that row. So each one of those 4 numbers that we have, we'll use score as the placeholder and then add those to our row total. So we're going to do row total plus equals 1. Once we get that, we'll do plus equals 2, and then plus equals 3, and plus equals 4. So add them all together and get the value 10. That will complete this inner for loop. We'll come to our print statement. We'll print that out. So that's going to be this 10.0 right here. We will then come back to the beginning of our outer for loop. So we're going to go ahead and get the next row. So that's going to be for 5, 6, 7, and 8. When we start trying to use it right here, if we don't include this line, we're still going to have the 10 from the previous iteration. And we want to make sure that we zero this back out because we're trying to get each row's individual sum. So if we were to take this out, for example, and we run this, what's going to end up happening is we're going to have 10 right here. We're then going to use that 10 with this, so it's going to give us 36. And then we're going to use that 36 here, and that's going to give us 78. So by the end of this, we would just end up with the total of the entire two-dimensional array. So if I try this, we can see the issue that we run into there. We want to make sure that we zero this out each time we go through this. And then for the last one, we'll take a look at calculating the total of the columns of a two-dimensional array. For this one, we're going to follow the same process as calculating the total of the rows, but we're going to invert the rows and columns on the for loops. So essentially, we're going to start with the outer for loop going through the columns, and then the inner for loop is going to go through the rows. And so because of the fact that we need to invert the logic for this, there's not really a way to achieve this with the for each loop. So instead we have to fall back on the traditional for loop in order to do column sums or column totals. So we'll go ahead and minimize this. We'll come over here. And so we'll go ahead and create one more double. We'll call this one call total. So equal to 0.0. We'll go ahead and save that. And then right down here, let's go ahead and comment out this portion. And then we'll go ahead and put together the logic for our column totals. So for this one, it's pretty much identical to what we had to do for the row totals. We're just inverting when we step through the columns and when we step through the rows. So we're going to do for int call equal to 0. And while the call is less than, in this case, we're going to be doing it as long as it's less than the size of one of those inner arrays, since that's where our columns are concerned. So we can say something like scores, let's say 0 dot length. We'll do scores plus plus, or call plus plus. And then right here, we can first make sure that we are resetting or initializing our call total back to 0. Since we need to go ahead and restart that every time we move to the next column, just like when we move to the next row in our row total. And then right here, we're going to have our inner for loop. So we're going to say for int row equal to 0, and then row less than scores dot length. So this one now is going to use the outer array's length. So row plus plus. And then our one line that we need inside of this inner for loop is to just add each one of these things to our call total. So we're going to say call total plus equals scores at the position of row and column. And then at the very end, we can also go ahead and print this out to the console. So we'll say system.out.println. So we'll go ahead and print out the call total for each one of our different columns. And again, we have to make sure that we do this print statement inside of the outer for loop. So we'll go ahead and run that. And so for this one, we get 4 different values. So we're going to get 15 for the first one. So that's going to be the sum of 1, 5, and 9. We get this 18. That's going to be the sum of 2, 6, and 10. 21. It's going to be the sum of 3, 7, and 11. And then 24, going to be the sum of 4, 8, and 12. And so the general idea here is that when we start with this outer for loop, we're stepping through each one of the columns. And for this inner for loop, we're stepping through the rows. So we're going to go through all of the values of, in a particular row, the same column. So we're going to go through 0, 1, and 2, all for column 0. That gives us our call total for the 0th column. We would then iterate to the next one. So we'll go to column 1. And again, we'll go ahead and do rows 0, 1, and 2 with this inner for loop. And each time that we do this, we're also making sure that we zero out the column total at the very beginning. Otherwise, again, if we leave this out, do something like this, and we run it, then again, we'll run into that problem where we're taking the previous column's total and adding that onto the current column's total, so that by the end of it, we would just get the total of all of the columns. So actually, we keep that line in there. So for passing and returning two-dimensional arrays and methods, this is going to be identical to one-dimensional arrays. Again, a reference to the array is going to be passed to or returned from the method. So the same general problems or lack of problems will still be present. So if you're doing something in the main method and then you make a call to one of these methods, passing in an array, a two-dimensional array, again, if you intend to change the contents of that array in the other method, you would make sure that you create a copy of it first so that you don't accidentally modify the array in the main method. Alternatively, if you're returning something from it, like returning an array, a two-dimensional array from a method, you don't really have to worry about this problem because of the fact that the method will terminate and essentially be destroyed after that. So again, the same general problems that you saw with one-dimensional arrays, just keep all of that in mind with two-dimensional arrays. So one particular thing that is a little bit interesting with two-dimensional arrays is what are known as ragged or jagged arrays. These are going to be arrays that have heterogeneous array lengths for the inner arrays. Heterogeneous just meaning that each one of the inner arrays will have a different size or a different number of items that you can put into it. When you're initializing the sizes of the array, the dimension for the inner arrays, so the second subscript, can actually be left empty. Arrays of different sizes can then be assigned to each position of the outer array. So in this case, we've created our two-dimensional array of ints called ragged. This is going to be equal to a new two-dimensional int array where the number of arrays that we can have is going to be 4, but we did not specify a size for each one of those inner arrays. So we left the subscript for the second pair of brackets empty. So then we can take each one of those arrays. So we can take the array at position 0, the array at position 1, the array at position 2, and the array at position 3, and we can go ahead and assign to them a new integer array, so in this case a one-dimensional array, of a different size for each one of them. So you can see right here we've got new int of size 3, new int of size 4, size 5, and size 6. So when you're dealing with ragged arrays, this is going to be another reason that you should rely on for each loops. It's going to eliminate the need to keep track of the length of each individual row in most cases. So this helps to simplify the process of stepping through each one of these inner arrays because of the fact that in order to do that, as we've seen with something like our column calculations, or if we're dealing with just using a traditional for loop for something like printing the contents to the console, you notice that we have to constantly use the length of the outer array, and we were working under the assumption that the lengths of each of the inner arrays would be constant, but that's not necessarily the case here. Instead, what you would have to do if you're going to deal with a ragged array, let's use this particular one as an example. So at that point, you would want to make sure that you're using the, for this particular one right here with the subscript, you would have to make sure that this subscript is updated to match the current array that you're on. So like if you're trying to do it with column totals, then you run into a bit of a problem where some of them will be empty because the lengths are different. Trying to do it with ragged arrays becomes very difficult because of that. Maybe considering it with row totals will help to simplify the process a little bit. So if we're dealing with row totals, we've got something kind of like this. Let's say we take this portion right here. Can undo that for a moment. We'll go ahead and grab that. So copy that down. And so when we're dealing with our row totals, if we write this out saying something like int row equals 0, row less than our scores dot length, and then row plus plus. So this will be our outer for loop. We'll go ahead and initialize the row total back to 0 each time. And then for our inner for loop, we're going to do something like int column equal to 0. And then we're going to say while this column is less than scores at row dot length. And then we're going to do column plus plus. And then right here, we'll go ahead and add on our scores for that row and column. So this would be how you would have to put together the logic if you're going to keep in mind doing this with a traditional for loop, and you also wanted to make sure that if this is a ragged array, that you are getting the size of the specific array that you're currently looking at. So if each one of the arrays, so each row, could have its own unique or distinct size, kind of like what we were looking at with all of this right here, then we need to go ahead and make sure that we're actually getting the length. So we're getting the entire length of a particular row in scores, so specifically the one that we're currently looking at. But alternatively, if you just use a for each loop, like what we have right here, then this structure we have right now already still works exactly the way we intend for it to, because of the kind of internal logic of how the for each loop works. So keep that commented out, and we'll keep this commented out. Okay, so that'll cover everything for our two-dimensional arrays. So now we'll take a quick look at three-dimensional arrays. So with a three-dimensional array, we can see a declaration and a construction right here. So we've got this three-dimensional array of doubles that we call seats. This is going to be equal to a new three-dimensional array where the three different subscripts are going to be 3, 3, and 4. So the way that we would describe this now is we're still going to have rows and columns, but now the extra dimension that we're introducing is going to be used to describe our different pages, where each page will have a collection of rows and columns. So in this case, the first subscript will describe the number of pages, the second subscript describes the number of rows, and then the third subscript describes the number of columns. So in this case, we've got 3 pages, 3 rows, and 4 columns, and we can see based on this figure that we have right here, we've got pages 0, 1, and 2, rows 0, 1, and 2, and then columns 0, 1, 2, and 3. So with our three-dimensional arrays, we've got this third dimension where we've added a depth, some number of pages, along with our rows and columns. This can also be described as an array of two-dimensional arrays. So each one of these pages is a two-dimensional array. So then we would just say that our set of pages is like an array of two-dimensional arrays. If we're dealing with arrays of more than 3 dimensions, so once we start to go beyond this, it's somewhat difficult to describe this using an abstract visual metaphor. So once you go past depth, once you get into a 4th dimension, it can be kind of somewhat complicated to keep track of precisely what goes where. But there are going to be some practical cases for using arrays with more than 3 dimensions. So as an additional thing to kind of leave you off on, I want you to consider certain scenarios where it might actually make sense to use arrays of several dimensions, like 4 or more dimensions. And with that, I'm going to go ahead and wrap up on our 2-dimensional, 3-dimensional, and higher arrays. Getting into the next video, we're going to start taking a look at some additional areas where we can make use out of arrays, which is going to include things like our command line arguments. So we'll see a little bit about using arguments from the CLI, as well as variable length arguments, which is going to come with the way that we set up parameters in our methods.